Recently we made a video with premium hi-fi, and it did pretty well. There were a lot of comments, and Arkady asked if I could prepare answers to some key questions. Let's take a look at the bigger picture. We had artificial intelligence analyze all these requests, responses, and how everything looks. I'll be honest, when I agreed to make one video, I was a bit skeptical about how everyone would react. Especially since Russian is not my native language and it's hard to speak it. Of course, you can feel all of that and you wonder how the audience will react to it, but overall, look, everything is very positive. 60 to 70% actually reacted positively, and I'm grateful for that. So it makes sense to make new videos and put a certain amount of work into it. Well, the skeptics, or those who, I don't know, write really bad words, they're only about 20 to 30%. This creates a kind of positive internal conflict, both for journalism and for bloggers. This is for premium hi-fi, where I play more of an engineer's role, but let's say the content, the ideas, what to talk about, that's definitely premium hi-fi. That means he picked everything correctly, and I'm just trying to learn what he does, how he does it, why it works, and so on and so on. But if I look at the comments and try to group them somehow, I would say there's one key question, or maybe two, but overall just one. I think it's about power and watts. There were a lot of different comments, and everyone thinks that high power isn't necessary, so I'll focus my answer specifically on these power levels and why it's so important. And the second comment, where there are a lot of different opinions about whether Class D rules or not, but that's simpler. Yeah, that's simpler. The question about power is more important. It's more important, and let's start by analyzing it. When we talk about how much power, I could calculate it, but what would people say in the comments? We don't trust calculations here. There are different ways to calculate. There's no speaker sensitivity and many other things such as distance and how we listen. All of that is true, but if we take an average scenario, we have an amplifier that can work with both small speakers and large speakers. Small speakers have low sensitivity, which means you need more power to drive them. Large speakers are usually placed in more spacious rooms. They need even more power. Yes, they are more sensitive, but they work in bigger spaces. We don't listen to them from 1.5 meters away, but from 3 or 4 meters, and as we know, sound waves decrease in proportion to the square of the distance, which means for every meter you lose 6 decibels. And the question arises, what real power should there be so that both a small speaker and a large one have enough? And I picked out a video for you. This specialist is an engineer, a former engineer from BBC who later started a small company. They operate partly as a private company and partly receive government grants for investigations. Basically, they develop loudspeakers specifically for the most discerning listeners, and for BBC when you need very precise reference monitors. They know everything about these loudspeakers. Actually, I recommend this specialist. He's not just an engineer, he's both a researcher and an engineer in one. He has very good expensive equipment to measure everything. He also has various experimental options, where they order diaphragms for speakers made from different materials, including composite materials. They make these speakers, then create some speaker systems where they use very simple enclosures, but everything there is about the sound. If the last 5% are anywhere, it's here. And they have a short video that shows, together with the dealer, they measure the peak power during normal listening of a regular speaker. And I picked out one video. Look, this video right here. How much amplifier power do I really need? And I recommend everyone to listen to this video. Yes, it's in English, but you can read the transcript and you can translate it. I don't know, maybe there's even an automatic translation. It's hard to say. But in any case, you can understand something from it. I'll make a general summary for you, and you can watch the whole video for the details. In general, I recommend listening to and watching this specialist. He has quite a lot of educational topics and videos like this, and a great specialist explains the nuances there. Nuances of the sound, really. Those who work in the last 5%, the very, very best. I'll quickly explain what they're doing here. So, they have two solid speakers. Actually, they're expensive. They look cheap, but they're really expensive. Everything relates to these speakers, to their accuracy. They have two monoblocks, each with a kilowatt, and there's a built-in peak power meter when they play different kinds of music. So, what conclusions did they draw? They listen to it, and they're already pretty far along. They listen from 2 to 3 or 4 meters. And the room, in my opinion, is relatively large. And what did they get when they listened to this kind of electronic music where there's a serious bass? So, the peak power during normal listening, not loud, is 500 to 700 watts. A kilowatt amp is just barely enough. When they listen to, I don't know, a string trio, but there it never goes above 20 at all. So, what's the conclusion? This is it. Those who say my tube amp, it has, I don't know, 10 watts and it sounds so good. With certain music it really does sound very good. But as soon as we set the task for it to sound good with all music genres, including modern electronic music, there's also that boom tss music where the boom is big and the tss is small, and those booms really do require peak power. So let's say our amplifier has, I don't know, 35 watts. It cuts all of them off, no exceptions. It doesn't play it the way it was recorded in the studio. You can listen to it, but for tubes it smooths everything out, gives you a soft bass, but that's not good. Yeah, it doesn't meet any standards when it comes to accurate music reproduction. If we like it, that's fine, but if the goal is to play back any music exactly as it was in the studio, it turns out that power plays a serious role. And let's take a look together at why that is. Yeah, why? Why do people comment, what 500 watts? I put a power meter on the mains and it barely shows 20 or 30 watts. What 500 really? What is he talking about? Or others say, just turn it all the way up and you'll see what happens then. No, we're not turning anything all the way up. For example, we usually listen to normal music at 70 to 90. Let's take a look. Here we have 70, and we follow this curve. Well, up to 20 means plus 10 decibels. On the low frequencies, yes, well, if it's up to 20, it's off the charts, plus 20 decibels in sound pressure. And knowing that the relationship between power and sound pressure is logarithmic. So if we have a difference of 20 decibels, that's 10 times. If we have 10 watts here, then 10 squared is 100 watts. Here, we're losing by 10 watts. And there we already need 100, right? If we move further away, all of this increases. So, even when recording in the studio, the low frequencies are recorded at a higher level, a seriously higher one. And secondly, if we look at the musical spectrum, at how we enjoy listening, it's kind of sloping down, right? The high frequencies are really low. Maybe the tweeter is at full volume when our ears are already ringing. That's just 1 watt, right? 1 watt. On average, well, 1.5, 2, and here the difference between 1 kilohertz is about 100, 150, well, somewhere around 50, 100, where we have the bass. The difference is about 30 to 40 decibels, right? These are peaks. That's 40 decibels. By voltage. That's a lot. And it turns out that we're listening kind of quietly, but the bass is off the charts. You also need to keep in mind when we're looking at the full picture, we're controlling a three-way speaker. The tweeter is like a motorcycle. If we compare it to cars, this mechanism very accurately repeats the same physics as a car. So if the tweeter is a motorcycle, 1 kilohertz is a light car, then the bass is a truck, right? And all the sound comes from acceleration. So we have to supply a huge amount of power to sharply accelerate this heavy, massive cone at low frequencies. It has size, it has to push this air, it has a big motor, it has a big coil, it has a relatively large mass compared to everything else. So that's where all the power goes. Remember, sound is only acceleration, so it's only present while accelerating from zero to something. This powerful short peak, only then is sound pressure created. If it just moves back and forth, there's no sound pressure, only acceleration. And we have to push this peak, the woofer, forward. This peak is relatively short. Well, one such push, it's less than a second. Yes, it has a front and must jump there now. You know how you have to press on the gas pedal for a truck to move, or even for a car when it starts at a green light. Look at the odometer. If on the highway it's, 4.5 to 5 liters. Then from the start, it's 50. These 50 are the peak short-term power. It's very important. That's where those 500 watts are generated. There's another definition we need to understand. These are temperature definitions. RMS is a temperature parameter, showing how much heat is generated with different signal shapes. We see that if we have a rectangular shape, we get 1. So the heat that's generated is the internal area of this signal. And if we take a sine wave, its internal area is different from that of meandra. And in different signals it's calculated here. We have RMS and the reverse factor, or reverse parameter Crest factor. I have a cheat sheet here. So, in Russian terminology, a high Crest coefficient is the Crest factor, and examples are given. In general, music is completely different from a sine wave in terms of heat. It has peaks, and then a small constant power, and if you compress it hard like that, then this whole range narrows, and there's no crest factor. A high crest factor, the crest factor changes. Yes, it consumes more power, but poor speakers sound better. That's why they compress them so much. And there's also this rule that when amplifiers are designed, we take these peak requirements into account. And the higher the quality of the music, the greater its acoustic dynamic range. Well, the whole system should have a large dynamic range. We need to let those high peaks through, not limit them. Then it will be good. This one is very important. What other conclusion can we draw? So with thermal sine waves, it's less than a rectangle, but what happens if we overload it? We'll start to limit it, so this signal will become more like a square, and much more heat will be generated. So we shouldn't limit it either. I'm talking about harmonics and other problems that will arise. The system starts to overlap if we go off the scale there. And you have to keep in mind that a tube amplifier has a high power supply. Yes, it's, about 150. For bigger tubes it can go up to 800, but the output power isn't that high. They are not limited by voltage, but transistor ones cut it. They cut it like a knife. Huge distortions appear right away. Well, it all depends on the calculations, but here it's RMS. Yes, RMS. Anyone who wants can go through the formulas. But that's not today's task. Here's a comparison. We have a sine wave. and there's a sound signal, and that's a difference of about 8 to 10 times. In terms of thermal ratios, we have sharp peaks, and then there's la 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 la. Here's the average here. And the sine wave is here. And also for modern amplifiers, especially Class D, well, what does the old school do? I submitted it, I don't know. A sine wave at full power, my thermal protection kicked in. Actually, it doesn't hold anything at all. That's not true. The amplifier and the power supply should be designed to work well at those peak values. You need to see the peak. Nothing drops, nothing sags, it delivers it right away. They don't care about average power. If we put in heat sinks just to run a sine wave, the size will just increase and it will all be expensive. It doesn't make sense. A good engineering design should take this crest factor into account, and the volume amplifier. It's designed to reproduce the audio signal, and that's it. Well, in general, you can read all the definitions yourself. The formula is given. I even found it in Russian and copied it, but I won't dwell on it here. Well, so that's a summary. We need to generate the musical signal with the power amplifier in such a way that it can clearly, efficiently, and without any problems provide the peak power. The peak power is 500 watts for a short period of time. But that means that all the components, starting from the power supply, ending with the output transistors, could deliver all the current needed for a short period of time, and all the power needed to the load without delays, without voltage sagging, and so on and so on. Let's also take a look at how much pure power we have. So, here we have a graph of a very good amplifier that can work with all loads with low distortion, and its rated power is 600 watts per channel, but 600 watts is already at high distortion. We have this range, which is like a reserve, but we only want to work in this one. So, from 1 watt up to at the peak, so that we don't go further than, I don't know, 450 to 500 watts. We're not interested in anything beyond that. That's the reserve. And it turns out that the 600 watt one is actually a 450 watt one. Pure quality. This is still good. I picked out one amplifier that can work with both 8 ohms and 4 ohms. And if we have, according to the usual architecture, here is one. This is Purify, a very good amplifier. Well, what do we see? So, at 4 ohms, it can deliver here 100, 200, 300 clean. And at 8, well, 150. We pay thousands there for some low distortion, but not enough power. Basically, we need this kind of amplifier in a bridge configuration. Then it will work. Otherwise, the price just skyrockets who knows where. So, to all the 100-watt enthusiasts out there, yes, we can listen, but our peaks are limited. We need more power, and then any music will play at an acceptable listening level, absolutely clean, without strain. I also want to draw attention to the load the amplifier is working with. This is the speaker load, the input impedance of the speaker. And when it comes to amplifiers, we often hear that the class is too old, or the class is, oh, that's the best one, or the tubes are even better, and so on. But you should understand, an amplifier is a dumb beast. It should, if its internal gain is 10, it gets 1 volt at the input and gives 10 volts at the output for any load. In electronics, this is considered a special case. It's a constant voltage source. Or, well, it's hard for me to translate, but the point is that regardless of the load, it outputs an amplified version of what's at the input. If there's 1 volt at the input, there are 10 volts at the output, regardless of the load. An ideal amplifier like this has infinite power and infinitely low output resistance. But in reality, that's impossible. So we have enough power, and we're considering working with a load from 2 to 50 ohms. For example, if we have 10 volts across 2 ohms, our output power is 50 watts. With 10 ohms, our output power is 10 watts. And regardless of the load, it performs. If we take a tube, and the tube has a high output impedance, then you get this division. If there's not enough power, yes, everything sags. But if there's enough, it works like an ideal amplifier. An amplifier shouldn't have a character. What does character mean? Well, for example, one character, I won't carry heavy things, I'll only carry light ones. I'm such an aristocrat. That's a tube amplifier. Or, on the contrary, I'll only carry heavy things, I won't carry the light ones at all. This is a powerful amplifier for concert sound, but for it to deliver both quality and power, that's difficult and expensive, objectively. Each one separately we can perform easily. And again, coming back to the Crest factor. So, I took a good industrial power supply that can deliver 600 watts per channel. It has such temperature or power-related. What sine wave can you feed into them? You can use a sine wave up to 280 watts. Yes, that's how it's rated, but if you recalculate it for music power, since it's rated by thermal parameters, you multiply by 8 and get 2.2 kilowatts. That's the rating. 600 per channel totaling 1.5 kilowatts for 2 channels. With a margin, it reserves 2.2 kilowatts based on thermal specs. So, if this one, 2 times 600, is running at full power, then we can measure it from the mains. It almost never exceeds 180 watts. And what will a young measurer say? He'll say, this amplifier, I measured it from the mains. It can't do anything. That's bullshit. You just need to understand the physics. And delivering this peak power is extremely difficult. I think in one of our future recordings we'll take one unit and see how the engineers, they did all sorts of things to make this peak power truly effective. They really put in a lot of effort there. A difficult task. But a power amplifier doesn't have to provide a sine wave for 5 minutes or anything like that. A modern one. In the past, they made them like that so they wouldn't cut corners on the transformer, but in today's conditions, that's an unnecessary parameter. Peak power is the most important thing. If the bass kicks in, there will be a punch like that, you know. Emotionally pleasant, light, clean, and so on and so on. Peak power, that's very important. And when modern amplifiers list their rated power, that's peak power, not thermal. Peak power, what it can put out temporarily. And in conclusion, I want to show you where the world is heading, or where developments in acoustics and high-quality, precise sound are going, and what opportunities these new technologies give us, including Class D amplifiers. This is Purify. Many people know Bruno Puzzis, who created the entire Hypex lineup, and then, together with other engineers, he started another engineering company. Hypex remained as a large commercial investment company. Bruno develops amplifiers within the company, and others work on loudspeakers, but at a different, more scientific level, because loudspeakers are still a weak point, and many things there are still not standardized. Especially all these electromagnetic processes with adhesives, magnets, and so on. Different distortions appear there. These guys decided that they would solve this problem, and I'm sure they can. Some people there are responsible for various pulse solutions. These are mostly power supply units, mainly the most complex ones. And they're all CEOs there, yeah, co-founders basically. They all have shares. But this company was created as an engineering firm for various other companies. They develop different things, and they have high-end developments or a store. God knows how that whole business structure is set up, but those same guys created some products of the future. How will everything change when we have technologies that aren't limited in power? There's this company called Key. If we look at the products, let's take an average one, not too big, and what do we see? I just want to point out how much power there is here. This speaker has 1.5 kilowatts. It's an active speaker, and then everything is described there. Simply put, to get a very precise, clear, absolutely accurate sound, the speaker is made less sensitive, and the amplifiers have more control over them. Power is no longer an issue. It used to be a serious problem and made this impossible at a reasonable price, but now it can be done. They went down this path and are now creating a new type of speaker, and since they're ahead of the entire industry, they're selling them at a high price again. But it's just a trend. When people tell me that 500 is a lot, 500 is not a lot. 500 is actually quite conservative. If you look at a floor-standing speaker, yes, 3.5 kilowatts is easy, but then you have the opportunity to make very clear, precise speakers. There's no muddiness there. It will play at any volume, and any room will sound good. But if you look at the prices, I'm not telling anyone they need to buy this. I'm just saying where the trends are going. When you're at the very peak of quality, but you have a different client, well, that's 7,000. But there, it's the very best of the best, for those who want only the very best. It's compact, has very high power, and it will perform well in any room. But power plays a big role. And my 500 watts, guys, that's actually a conservative estimate, really. But personally, I believe that with 500 watts, we can drive any modern speaker for proper listening. That's the last 5, maybe even 2%. Do we really need it? No, not for me, but who needs it? There are no expensive things, there's just not enough income. Yeah, I get that. But I would say this, 500 watts is really good power. If you have that, you can play any modern speaker with excellent quality. And today, that's been taken care of.